Good morning, everybody. Today we are going to start the Unit 2 test review. We'll do that today and tomorrow. So we're going to look at the odds today, evens tomorrow, and then you'll have your test at the end of the week. So let's get going. All right, so let's go ahead and get started. You'll notice in the directions for each of the examples, it specifically states what you're going to do with those particular examples. So for numbers 1 through 4 in the test review, we're just going to factor with a GCF. So again, we're looking to see the greatest common factor to be a number and or a variable. In example 1, we have 6a cubed plus 54a squared. So both of those terms are divisible by 6 and by a squared. So when we that's our GCF, and then when you divide through each term by 6a squared, remember we put that GCF, we list it first, and then we do our parentheses. 6a cubed divided by 6a squared is a, and 54a squared divided by 6a squared is 9. So in factored form, 6a squared multiplied by the quantity a plus 9. Cool. All right, number 13, 18x to the fourth minus 30x cubed. Both of these numbers I know are divisible by 2 and by 3, so that means they're divisible by 6. And then when I look at the x's, I have x to the fourth and x to the third, so my GCF can be 6x cubed. Just like we did for example 1, I'm going to divide each term by 6x cubed, that GCF. And I will list it as the first factor, and then parentheses, whatever's left when I divide. 18x to the fourth divided by 6x cubed will just be 3x, and negative 30x cubed divided by 6x cubed will be a negative 5. So factored form is 6x cubed multiplied by the quantity of 3x minus 5. All right, our next ones, numbers 5 through 8, we are factoring difference of two squares. Remember, we're looking for the difference, the minus sign, only two terms, and that they're perfect squares, meaning I can take the square root. So in number 5, r squared minus 36, I have a minus, only two terms, and I can take the square root of r squared, it's r. And the square root of 36 is both positive and negative 6. Those become our two factors, r with a plus 6 and r with a minus 6. If you were to go through and multiply them back together, you would get exactly what you started with. The terms in the middle, when you add them together, would cancel or equal 0. All right, number 7, this one's a teeny bit different. It is a difference, only two terms, but there's not perfect squares. So we have to go back to what we always do first. That's right, a GCF. Each of those terms are even. Start with 2. Look to see if that's the biggest that you can divide through. So 2x squared divided by 2 and 98 divided by 2 will give us 2 for GCF, and then x squared minus 49 in parentheses. Now our x squared minus 49 is a difference of two squares, and we can follow that same pattern by taking the square root of x squared to give us x, the square root of 49 to give us both positive and negative 7. The kicker with this one is you have to remember to keep your GCF. So the factors are 2, x plus 7, and x minus 7. Don't drop off that GCF. All right, we are rocking and rolling. Let's keep going. Alrighty, in examples 9 through 12, we should be doing 9 and 11, but I wanted to do 12 in this example, so you're doing 10 and 11 when you do the evens. All right, so these are all trinomials. So you see I've got that little diamondy shape already gone. It's already set up. So we're going to multiply A and C to give me the number up top. So their product of A and C, and then gives me the sum of B. There we go. So in number 9, our leading coefficient is 1. 1x squared multiplied by the 22 gives me positive 22. So what are factors that multiply to 22 and add to that middle linear term, negative 13? Those are going to be negative 2 and negative 11. And again, you can find those in your little factor chart that you have in your notes. Because I just have an x squared, that leading coefficient is a 1, I'm just going to put an x over top of each of the factors we just found of 22. Then I'm going to check these factors, x and negative 2 and x and negative 11. If they don't reduce, those are your factors, x minus 2 and x minus 11, and you're done. Awesome. Cool. So when we do number 12, it says down here that I corrected the typo in number 12. There was a typo originally. I have since fixed it. So here we go. First in number 12, I noticed that 21 and 36 are both divisible by 3, and so is 120. I'm not looking at the signs, just the actual numbers. So right now I know there's a GCF of 3. I'm going to factor that out. So 3 on the outside, and then everything else left over when I divide through, 7p squared minus 40p minus 12 goes inside your parentheses. Now we're going to use this quadratic, 7p squared minus 40p minus 12, to get our product, a and c, and the sum of b. So what multiplies 7 and negative 12 to negative 84 and has a sum of negative 40. So those numbers are 40 digits apart, like 2 and 42. And we need the 42 to be negative so that when we add 2 plus negative 42, we'll get that negative 40 value at the bottom. All right, this example is different because it has a 7 coefficient in front of the p squared. It's not a GCF, so I'm going to bring down a 7p over top of the 2 and the negative 42. I'm going to check the factors, 7p and positive 2. That doesn't reduce, so that factor is good. When I look at 7p and negative 42, they are both divisible by 7. So when I divide them through by 7, I get p and negative 6. That's the most simplified reduced form of that second factor. Okay, so we had a GCF at the beginning. We got to list that, 3, and then our factor on the left, 7p plus 2, and then our factor on the right, p minus 6. Great job. You guys are rocking it. Now we're going to solve by factoring. So we've practiced how to factor each of these types. Now we're going to take it an extra step. Numbers 13 and 14 are GCF only. Okay, so for number 13, I'm going to check for the GCF. Well, 8x squared minus 8x equals 0. I notice that both of the terms are divisible by 8x. So let's factor out the GCF, 8x. Remember, that's the same as dividing through. That'll leave you with an x minus 1. So it's 8x multiplied by the quantity x minus 1 equal to 0. So that's my second step. Then I'm going to set each of those factors equal to 0. So I'm going to say 8x equal to 0 and x minus 1 equal to 0. When we solve, to solve for 8 times x equaling 0, we divide by 8, so x equals 0. And to solve for the other one, x minus 1 equals 0, I have to add 1 to both sides of the equation, so I solve to get x equaling positive 1. Remember, as you look at the exponent, it'll tell you you can have up to 2 different solutions, and we did in this example. Moving along, numbers 15 and 16, we are going to solve the equation by factoring, and we're going to use the dots method. So 15, we have x squared minus 25 equals 0. So first, make sure you isolate the squared term, x squared, p squared, n squared, whatever it is. Okay, that's already done for us. Then we get to square root both sides of the equation. All right. So after I added 225 to each side, I got x squared equaling 225. Now I'm going to take the square root of both sides. When you take the square root of x squared, you get x. When you take the square root of 225, you'll notice I got positive and negative, and when I simplify it, I'll get 15. So our two solutions are x equals 15 and x equals negative 15. And I misstated earlier in this one, it was not already, the x squared was not already isolated. We had to add 225 to both sides of the equation first. I missed that step. All right, numbers 17 and 18, we're going to solve by factoring. These examples are trinomials. So we are going to set it equal to 0, factor, set the factors equal to 0, and solve. Just like we did if we just had a GCF. So for number 17, I have k squared minus 7k minus 8 equals 0. I'm looking for a multiplied by c, the product. 1 multiplied by negative 8 is negative 8. So it multiplies negative 8 and has the sum of the middle coefficient, negative 7. Okay, my factors I will use will be -8 and +1. -8 times 1 gives me -8, and -8 plus 1 gives me -7. It's only a k-squared term, so I'll pop a k on top of each of those values that I got as the factors of -8 and check to see if they reduce. K and -8 do not reduce. K and +1 do not reduce. Okay. Those two factors are set equal to 0. So k minus 8 can equal 0, or k plus 1 can equal 0. When we solve them individually, if k minus 8 equals 0, I add 8 to each side of the equation, giving me k equaling +8 as a solution. For k plus 1 equal to 0, we need to subtract 1 on each side of the equation. So I get k to equal -1 as the second solution. Yay! We are so close to being done. All right, number 19. All right, this was the very, very, very first lesson that we did like 3 weeks ago. A little rusty. Remember, we're going to use either scientific or graphing calculator, whichever one you want, doesn't matter. For number 19, we've got to sketch the graph and then state the solutions. So our notes are to use whichever calculator you want. Look at the table. Okay, so we're going to type it into y equals either the table button on the little calculator or the y equals button in the top left corner of the graphing calculator. And then we're going to look through the ordered pairs that we have. So I just grabbed some that went from x equaling -5 up to x equaling +3 and looked through those particular points. I do want to make sure that my vertex is included so that I really do see the graph. -5, -12 is not, or excuse me, -5, 12 is not going to be on my graph. -4, 5 is not going to be on the graph either because of what was given to us. -3, 0, -2, -3, -1, -4, 0, -3, and 1, 0 are all going to fit. So we're really only going to graph the 5 points that fall between and including -3 to +1. Okay, so that's each of those points. You'll notice that when we connect the points, we do get that parabola U shape, and the vertex, is this minimum point, which is the ordered pair 1, -4 that you see right there in the table. And you'll see that pattern, each side increases in the same manner, going from the vertex. So in this case, looking for the solutions, I got a graph, check. Now I have to state the solutions. The solutions are, where does the graph cross the x-axis? Okay, well, there's the 2 points. We have 2 solutions, one of them at x equaling -3 and another at x equaling +1. So this graph has 2 solutions. You actually can also see them from the table, -3, 0 and 1, 0. So those y values in the previous one, if your y values are 0, then you're going to get solutions, your x-intercepts. Numbers 21, 22, and 23 want you to sketch a quadratic function with the requested amount of solutions. Okay, if you have 1 solution, you're going to cross the x-axis 1 time. That's it. 1 x-intercept crosses the x-axis once. That x-intercept is also the vertex. It'll be the minimum or maximum. We're going to skip 22 because it's an even, and we're going to do number 23. 2 imaginary solutions, not real, but imaginary. Imaginary solutions do not cross the x-axis. So in this case, there's no x-intercepts. Function never crosses the x-axis. It will always be completely above or below. You could sketch that same curve down below your x-axis. Great job. We made it to the 15-minute mark. All right, make sure you guys have good notes. You get to use these on your test. Have a great day, guys. See ya.